Welcome to this video where we're going to look at further algebraic division and finding factors. We're going to look at three methods, okay, of factorizing a cubic expression like this one. Now, the first thing to do in this case is to find at least one factor by inspection or trial and improvement, if you like. Now, we're not told any factors at all, but we've got to find all of them. So I'm going to start by suggesting to you that to get the 14 at the end, one of the factors must end in a factor of 14. So it must be 7 or 2 or possibly 1 or 14. So we're going to try x equals 1 first of all. So if we tried x equals 1, we would have 4 times 1 cubed, which is 4. 4 times 1 squared is 4. That's 8 so far. Take away 31 times 1. So that would take us down to a negative odd number. And then if we add 14, it's not going to give us 0. So that isn't 1 is not a solution to the equation f of x equals 0. I'll just call this function here, or this expression, f of x. Okay, meaning a function of x. Okay, so that's what we're working with. Now we're going to try 2. Okay, so I'm just going to put here x equals 2 question mark, so we can try it out, because 2 is a factor of 14 and it's usually quite a low number that they would give you in a question to find. So we're doing 4 times 2 cubed. Okay, so it's 4 times 8. Okay, we've also got to add on to it 4 times 2 squared, which is 4 times 4. Okay, and we've got to take away 31 times 2, and we've got to add 14. Okay, and hopefully it will be that. It looks about right. And when we check it out, we've got 32 plus 16, that's 48. If you take away 62, that would take you to negative 14. Plus 14 is 0. So it works. And that means that that implies that x minus 2 is a factor of that, Okay, so that's the starting point, finding one of the factors. Now, if we're going to do algebraic division, we simply set up a division. Now I'm calling it algebraic division, but I'm cheating a bit, because what I'm going to do is write the factor x minus 2 as 1, 2, or 1, negative 2, like that. And I'm going to divide that into 4x cubed plus 4x squared minus 31x plus 14. Okay, now you can put all the algebra in there, and in a previous video I've shown you how to do that, but you can take out the x and all the powers of x and just leave the coefficients in like that. And I'm saying here 1, negative 2 into 4, 4. And just look at the 1 and the 4, and it goes in 4 times. And then I multiply. 4 times 1 is 4. And 4 times negative 2 is negative 8. So I do a subtraction to see what's left over, and that gives me 4 take away minus 8 is the same as 4 plus 8, which is 12. Bring down the negative 31, and now I'm saying how many times does 1 negative 2 go into 12 negative 31? Just look at the 1 and the 12, it goes in 12 times. Okay, 12 times 1 is 12, and 12 times negative 2 is negative 24. Do the subtraction to see what's left over. And we've got negative 31, take away negative 24 is negative 31 plus 24, which is negative 7. Bring down the 14, and we should get an exact answer here. 1 negative 2 into negative 7, 14, goes negative 7 times, because again I'm looking only at the first number in each pair. Negative 7 times 1 is negative 7. Negative 7 times negative 2 is plus 14, which is what we have above, which means there's no remainder, as we expected, because we had just established by testing this out that negative 2 is, that x minus 2 is a factor, and therefore 2 is a solution to the equation f of x equals 0. Okay, so there's our remainder of 0, 0. And we now know that the function f of x can be written as the product of x minus 2 multiplied by the factor, the quadratic factor, 4x squared plus 12x minus 7. Okay, now we look at that quadratic factor and we ask ourselves, can that be further factorized? In other words, can we break that up into the product of two brackets? Well, we can. It's not immediately obvious what we have to do with the second bracket, but we're looking for a pair of factors of that will give us the minus 7, and it will give us the 4x squared. Now, the 4x squared can come from 2x times 2x or x times 4x. And with a bit of trial and testing, you can find out that it's 2x and 2x that works. And to get the negative 7, that can only come from either plus 7 times minus 1 or minus 7 and plus 1. Okay, and to get the 12x in the middle, that should be there, that should be 12x. To get that 12x in the middle, you would need to get, well, you see, 1 times 2x is 2x, 2x times 7 is 14x, and I would need to do the 14x minus the 2x to get 12x. So to get the 14, that would be a plus, and this would be a minus. Okay, and you can check that out by multiplying out those two brackets to see if you get that. So there is the full factorization of f of x using algebraic division and then factorizing a quadratic. Okay, different method altogether, equating coefficients. Okay, so what I'm going to do is I'm going to start with this, so I still have to find a factor. All right, so that's going to be very useful in both of the next two methods. Okay, so I still have to do that, but when I've got it, I can say that f of x is equal to x minus 2 multiplied by some unknown quadratic. Okay, so at the moment I haven't done any of this. I don't know what quadratic is, but I know that a quadratic looks like this: ax squared plus bx plus c. Okay, and I've got no idea what a, b, and c are because I haven't done this yet. I'm just starting again. So how do we find out what this is? Well, what we do is we say that if that's true, then f of x must be, and I multiply out these brackets. So x times ax squared is ax cubed. Okay, and I'm timesing everything in this second bracket by x, you see. Ax cubed plus bx squared, okay, plus cx. And then I'm taking every term in this second bracket and timesing it by minus 2. So I'm getting minus 2ax squared minus 2bx, and then I'm getting minus 2c. Okay, now those 6 terms that I've just created will condense into 4 terms because I've got only one x cubed term, but I've got 2 terms that contain x squared. Okay, so these 2 terms here, bx squared and minus 2ax squared, they can combine to give me b minus 2a times x squared. Okay, and next I have these two terms which contain x. So minus 2bx and cx. So in the next term, I can write that as c minus 2b, and that's all times x. And finally, I've got minus 2c at the end. So I've now got four terms, an x cubed, an x squared, an x, and a number. Now what I'm going to do is equate coefficients, because what I know for sure is that if I compare those four terms there with the four terms in the original, they must equal 4x cubed plus 4x squared, okay, plus minus 31x. I'm just putting them underneath each other, and the minus 2c must be the same as plus 14. Okay, so the 4x cubed is matching to the ax cubed, so therefore a must equal 4. Okay, and the minus 2c is equal to 14, right? So from this part here, I can say that minus 2c equals plus 14. So therefore, c must equal 14 over minus 2, which is minus 7. So I've established what a is, and I've established what c is. And now I've got to find what b is. Now I can either use the fact that b minus 2a equals 4, because that's comparing the x squared coefficients, or I could say that c minus 2b is minus 31. This is going to be easier to work with. So I'm from this part here, okay, I'm going to say that b minus 2a is equal to 4. But I know already that a is 4. So b minus 8 equals 4. So if I add 8 to both sides, I get that b equals 12. Okay, so if you compare what I've just done, look, I've got the a is 4, the b is 12, and the c is negative 7. And they are the coefficients a, b, and c in this quadratic. And you may have noticed that they also match what we did here. There's the 4, there's the 12, and there's the negative 7. So in other words, I've now got to the same situation I was here, and I would just finish it off as I did over here. Okay, so once I've got that information, I've basically gone back to what I had over here, and I would just do that. Okay, so what's this third thing that I've mentioned, synthetic division? Now this is really smart, and it works provided that you're dividing by a linear factor. So a linear factor is something like x minus 2 or 2x plus 3. Okay, so let's see how it actually works. Well, what I do is I take not the factor, but the solution. What was the value of x that caused this factor to be 0? Well, it was 2. So what I do is I write down the 2, okay, and I do a rather funny looking division like this. So there's a big bracket. It's a double row one with a line under here, okay, and next to the 2, I write the coefficients, 4, negative 31, and 14. Okay, it's really easy this. I start by bringing down the first thing, which is 4. Okay, just drop it down to there. Whatever that is, you just put it again there. Then I say 2 times 4 is 8. Okay, and then I add these together. 4 and 8 is 12. Okay, then I say 2 times 12 is 24. Put it there and add those two together. 24 and negative 31 is negative 7. Okay, and finally I say 2 times negative 7 is negative 14, and it should be the case that the last two, when you add those together, gives you 0. Okay, and then these three things here, the 4, the 12 and the minus 7, become the coefficients of the quadratic, just as we got here, and so now we simply go to this step again and do what we did over there to finish off. Okay, so that is 3 different methods. This one here, the synthetic division, is very quick, and as long as you obviously set it out correctly and do it as I've shown you, it works, provided you're just dividing by a single number here, which comes from a factor like x minus 2. Okay, so I hope that was helpful. Practice doing one that you've already done before, but using these other methods as well.